Okay, let's just jump straight into today's explainer because we are unpacking a truly mind-bending thought experiment. We spend so much time looking up at the stars, marveling at the sheer, overwhelming complexity of our reality, and we naturally just assume that our place in it is incredibly unique. But today, we're exploring a concept derived from the work of author Jacques Dax, and it challenges pretty much everything we intuitively think we know about our place in the cosmos. It is a mathematical and philosophical journey that's going to completely flip your perspective.
Right off the bat, I know that is a highly provocative question. It goes against our very nature as living, breathing, thinking beings to even entertain the idea. But setting aside our own egos for a minute is exactly the paradigm shift we need for this explainer. To really grasp the mathematics of universe generation, we have to ask ourselves, objectively speaking, is the existence of biology actually a miracle, or is it literally just one arbitrary outcome out of an infinite pile of possibilities?
So, to get where we're going, we first need to look at where we are. You're likely familiar with what's called the anthropic principle. This is the widely accepted observation that our universe's physical laws and constants, things like the exact speed of light, the precise mass of an electron, or the exact strength of gravity, are perfectly tuned. I mean, if you were to tweak any of these fundamental constants, but even a tiny fraction of a percent, stars wouldn't form, carbon wouldn't exist, and life as we know it would be entirely impossible. The universe just appears custom-built for us. And people really run with this, right? It's super interesting how the anthropic principle gets used in major philosophical debates. Many thinkers look at this insane fine-tuning and argue that because a randomly generated universe could almost certainly never support life, our highly specific configuration proves the necessity of a divine creator who set all the dials just right. Or, on the flip side, others use it to argue for a massive, infinite multiverse, where eventually a universe with our exact, life-permitting parameters is just bound to pop into existence. But what if that entire foundational assumption is just flawed? Let's dive right into the counter-argument, the Destropic Principle. This principle is a direct counter-argument that totally strips away our human biases. The core premise here is actually quite simple, but deeply profound. It argues that in any scenario of random generation, every single possible universe is equiprobable. That means the possibility of life, which we obviously value incredibly highly, is mathematically no more special of a characteristic than literally any other random physical property a universe might have. Any random universe would look uniquely and perfectly tuned to its own bizarre properties. Now, trying to actually picture alternate realities is practically impossible. So to wrap our heads around this highly unintuitive concept, the author uses a really brilliant mathematical analogy. Let's just compare the fundamental laws of a universe to something we can easily grasp, real numbers. If you think about all the complex constants of a universe kind of squished together into one long string, you can represent an entire, distinct universe as just a single numeric parameter. Which brings us to the core of our thought experiment, the universe machine. Let's imagine a hypothetical machine that has one job. It just spits out completely random real numbers between 0 and 10. Because we're talking about real numbers, the options are of course infinite. So the machine fires up, does its random calculations, and spits out this hyperspecific number, 4.22341. In our analogy, this number acts as the master parameter. It completely defines all the constants, the forces, and the characteristics of a specific universe. Let's call it U1. For the sake of our explainer, let's just say 4.22341 is our universe. So you look around at the immense complexity of our universe. You look at the stars, the galaxies, the unbelievably delicate balance of biology. And you ask, out of an infinite set of real numbers between 0 and 10, what are the odds of a random machine picking our exact universe? It feels like an absolute miracle, doesn't it? It feels so wildly improbable that it just demands an explanation, like a creator or a multiverse. Well, here's the kicker, and this is the crucial point. In a model of random generation, the odds of picking 4.22341 are practically zero. But, and this is the absolute genius of the Destropic Principle, the odds of picking any other specific number, like 6.12333, are also practically zero. Every single number, and therefore every single possible universe, is equiprobable. The machine has to pick something. Whatever it picks will be incredibly unlikely, meaning our specific universe is no more miraculously unlikely to occur than any other random combination. So what does this actually look like in practice? Let's talk about the unique characteristics of Vita, Vota, and Vuda. This perfectly illustrates the symmetry of the problem. Over here on the left, we have U1, our universe. Its parameter is perfectly tuned to generate vida, which is the Portuguese word for life used by the author. If you change a constant in U1, vida is destroyed. But look at the right. We have a totally random universe, U2. Its parameter is perfectly tuned to generate a completely different property. Let's call it VODA. Maybe VODA is a highly specific particle density of exactly 0.12221. If you change a constant in U2, vida is destroyed. U1 cannot make VODA, and U2 cannot make vida. They are equally, flawlessly specialized. Let's have a little fun visualizing this. Just imagine it. The machine generates a universe fine-tuned to create nothing but sentient, elastic slimes. If a hypothetical slime observer lived there, they'd look at their beautiful, stretchy appendages and exclaim, "Wow, our universe is so perfectly fine-tuned. If gravity were any stronger, we couldn't bounce." They could use the exact same fine-tuning argument we use to prove their grand slime creator exists. Or imagine a universe of just perfectly glowing micropyramids. And hey, this isn't just a quirky philosophical game. The author actually backs this up with a formal system of basic constants, which you see represented here as A through F. Mathematically, a random universe U3 depends absolutely on its exact constants to create its unique property, VUDA. If you change any constant in U3, VUDA is destroyed, just as surely as changing our constants destroys VIDA. The mathematical sensitivity is identical across the board for all possible universes. And that logically leads us right into the illusion of intrinsic value. See, to the universe-generating machine, or honestly to the cosmos itself, there is absolutely zero intrinsic difference or importance between generating biological life, a bunch of elastic slimes, or glowing geometric shapes. The machine has no consciousness. It has no desires or goals. It just generates a parameter. It certainly doesn't grade one outcome as a success and another as a massive failure. There's this fantastic point in the source material that just hits the nail right on the head. Quote, "For us humans, life might be more important than shiny crystals or elastic slimes, but that is merely a human valuation. We look around and consider our universe deeply unique and inherently special simply because we are the small, egocentric beings living inside it. We are literally just projecting our own intense, subjective preference for being alive onto the cold, mathematical canvas of the cosmos." So the ultimate conclusion of the Destropic Principle is simply this: there is nothing magically or miraculously special about our universe's probability. It is just one random pull from the machine. Because of that, we logically cannot use the fact that our universe hosts life as mathematical proof of a deity or a required sprawling multiverse. Any random outcome, no matter how weird or totally lifeless it is, would seem just as intricately fine-tuned and perfectly designed to its own unique parameters. It really is a humbling thought, isn't it? To realize that mathematically our existence is no more or less special than a universe full of glowing geometry. But, maybe that's actually kind of empowering. Because if the universe doesn't inherently value our existence over a universe of elastic slimes, then does meaning come from the cosmos at all? Or is it entirely up to us to just create it right here, right now? I'm going to leave you to ponder that massive question about where true meaning actually comes from. Thanks so much for diving into the Destropic Principle with me on today's Explainer, and as always, keep questioning the universe.